Hi everyone, welcome you all to this lecture about disk scheduling algorithms from the subject operating systems. This is C. Karpagavalli, Assistant Professor, Department of Artificial Intelligence and Data Science, Ramco Institute of Technology, Rajapalayam. Before we enter into the topic, we need to understand what is disk scheduling. Disk scheduling algorithms are used by operating systems to manage the read and write request of computer's hard disk drive. The main aim of scheduling algorithms is to minimize the seek time, rotational latency, and overall response time for disk I/O operations. These are the types of scheduling algorithms. FCFS, first come first serve scheduling, SSTF, shortest seek time first scheduling, scan disk scheduling, cscan disk scheduling, look scheduling, clook scheduling, random scheduling, last in first out disk scheduling. Before moving to the algorithms, let us understand some important terms related to disk scheduling. First one, seek time. It is the time taken by the disk read and write head to move to the place where the data is stored. High seek time means the disk head has to move a lot to reach the requested data. This will affect the overall performance of disk I/O operations. Second, rotational latency. It is the time taken for the sector containing the data to rotate under the read and write head to the correct position. It depends on the speed of the disk rotations. Faster rotation speeds make the rotational latency lower and the data can be accessed more quickly. Third, transfer time. It is the time taken to actually transfer the data after the read and write head reached at the correct position. This time does not depend on the disk head movement. It only depends on the amount of data being transferred and the speed of transfer. Then fourth, disk response time. It is the total time taken to complete a disk I/O operation. This is the sum of seek time, rotational latency, and data transfer time. If the response time is low, it means that the disk can quickly respond to read and write request. So the formula for calculating the disk access time, it is the addition of seek time plus rotational latency plus transfer time. Then the formula for calculating total seek time, it is the multiplication of total head movement into seek time. Let us start with the first algorithm, first come first served disk scheduling algorithms. So it is also known as FIFO, first in first out disk scheduling algorithm, is the simplest form of disk scheduling. So here requests are processed in the order they arrive. It means the request that came first will be served first. This will not depend on the current position of the disk head. So this image shows how the disk head moves for the sequence of request. So here the sequence of requests are 98, 183, 37, 122, 14, 124, 65 and 67. So the initial position of head is 53. So here the total head movement is calculated by the absolute differences between each request. So here the total head movement is 53 minus 98 plus 98 minus 183 plus 183 minus 37 plus 37 minus 122 plus 122 minus 14, then 14 minus 124 plus 124 minus 65 plus 65 minus 67. So the total head movement by using the algorithm first come first served disk scheduling is 640 tracks. Then second type of algorithm, SSTF, shortest seek time first disk scheduling algorithm. So in this algorithm, it selects the request that is closest to the current position of the disk head, which means the request with the shortest seek time will be served first, and this algorithm will not depend on the order of arrival of request. So comparing to FCFS, the total head movement of SSTF is significantly low. So this is because the SSTF always select the request that is closest to the current head position. So it minimizes the distance the head has to move for each request. So the image shows how the disk head moves for a request sequence: 98, 183, 37, 122, 14, 124, 65 and 67. So here the initial position of head is 53. So the total head movement is calculated, the absolute differences between each request. After that we need to add all the request. So here it is calculated by 53 minus 65 plus 65 minus 67 plus 67 minus 37 plus 37 plus minus 14 plus 14 minus 98 plus 98 minus 122, then plus 122 minus 124 plus 124 minus 183. So the total head movement by using SSTF algorithm is 236 tracks. So we can see the total head movement is reduced by using the SSTF algorithm compared to the FCFS algorithm. And third types of disk scheduling is scan disk scheduling. So in a scan disk scheduling algorithm, it works by moving the disk head in one direction, either left or right, and then serve all the requests in that direction until it reaches the end of the disk. So after reaching the end, the head reverses its direction and serves the request in opposite direction. This is also known as elevator algorithm due to its similarity with working of an elevator. So for example, consider a disk having 200 tracks and requests are arriving in the order 82, 170, 43, 140, 34 and 190. So the initial position of disk head is at track 70 and the head is moving towards the right. So the image shows how the disk head moves for this request sequence. So it starts from the track 70 and move towards right. So it serves the request 82, 140, 170 and 190. Then it reaches the end of the disk at 199. Now reverse the direction and move towards the left. Then serves the request 43 and 34. So here the total head movement is 199 minus 70 plus 199 minus 34. So the total head movement is 194 tracks. Advantages of this algorithm: it improves the response time for a request and reduces the variance in wait times for request. Then disadvantages: it can lead to longer wait time for a request located at the end of the disk. Then it is more complex to implement comparing to the FCFS and SSTF disk scheduling algorithms. The next types of disk scheduling is C-scan disk scheduling. It is also known as circular scan disk scheduling algorithm. So it is an improvement over the scan algorithm. In C-scan, the disk head moves in one direction, either left or right, and it serves all the requests in that direction until it reaches the end of the disk. So after reaching the end, instead of reversing the direction, the head jumps back to the beginning of the disk and starts serving the request in the same direction. So this algorithm is suitable for circular disk structures. So first starts from the track 70 and move towards the right. It serves the request 82, 140, 70 and 190. So reach the end of the disk at 199. So then it jumps to the beginning of the disk 0. Then now reverse the direction and move towards the left. So from the end 199 it moves towards the left. Then start serving the request 34 and 43. So here the head movement is calculated by 199 minus 70 plus 199 plus 43 minus 0. So the total head movement for this algorithm is 371 tracks. Then next types of disk scheduling is look disk scheduling. So the look disk scheduling algorithm is an improvement over the scan algorithm. So in look algorithm, the disk head does not go to the end of the disk if there are no requests in that direction. So instead, it reverses its direction as soon as it reaches the last request in that direction. So this way, it reduces the unnecessary head movement. So consider a disk with 200 cylinders numbered from 0 to 199. The current head position is at cylinder 70 and the requests are 82, 170, 43, 140, 34 and 190. So assume that the head is moving towards the right direction. So this figure shows the how the disk head moves for this request using the look disk scheduling algorithm. So here it starts from the track 70 and move towards the right. Then serves the request 82, 140 and 170, 190. Now reverse the direction and move towards the left. So again it starts 43 and 34. So the total head movement is calculated by 190 minus 70 plus 190 minus 34. So the total tracks are 276. Advantages of this algorithm: it reduces the unnecessary head movement comparing to the scan disk scheduling. It improves the response time for request. The next type of disk scheduling is C-look disk scheduling. So it is also known as circular look scheduling algorithm. It is an improvement over the C-scan algorithm. So here the disk head does not go to the end of the disk if there are no requests in that direction. Instead, it jumps back to the beginning of the disk as soon as it reaches the last request. So this way it reduces the unnecessary head movement. So here the example is given. So consider the same disk request arriving in the order 82, 170, 43, 140, 34 and 190. So here the initial position of disk head is track 70. Then the head is moving towards the right direction. So here the figure shows the how the disk head moves for the request by using the algorithm C-look scheduling. So here the request starts from the track 70 and move towards the right. Then it serves the request 82, 140, 170 and 190. Now it jumps to the beginning of the disk. So it now reverse the direction and move towards the left. So again it starts serving the request 34 and 43. So here the total head movement is 190 minus 70 plus 190 minus 34. So the total head movement is 276 tracks. So next type of scheduling is random disk scheduling. So the random disk scheduling algorithm selects the disk IO request any random order. So this algorithm will not consider the current head position, seek time or any other factors while selecting the next request to serve. So it is commonly used for testing and comparison purpose rather than in practical applications. Then last type is last in first out disk scheduling. It is just opposite to FCFS. So in LIFO algorithm, the most recently arrived request is served first. This means that The request that came last will be served first, regardless of current head position or seek time. So this algorithm is rarely used in practical purpose due to its potential to cause the starvation for older requests. Goals of disk scheduling algorithms. First one, it minimizes the seek time. The algorithms aims to reduce the total seek time by optimizing the movement of disk head. Then second, minimize the rotational latency. The algorithms tries to minimize the rotational latency by efficiently scheduling the request. Then third one, maximize throughput. The algorithms aims to increase the number of I/O operations that can be completed in a given time period. Then fairness, algorithms needs to ensure that all the requests are served in a fair manner. So this all about the disk scheduling algorithms. Thank you. Thanks for watching.